Today I am going to be discussing an article that goes into detail about a NASA system called SCOUT that utilizes the trajectory of an asteroid to predict when and where it will impact Earth. Before I start talking about the specifics of the article, I would like to just talk about what a trajectory actually is. So the term trajectory refers to the flight path of a body in space that have clearly defined initial and endpoints. In order to separate trajectories from orbits, scientists define trajectories as flight paths from the Earth to the Moon, while the term satellite orbit is used in reference to paths around the Earth. The type of path that a spacecraft takes depends on the sphere of influence it is in and its velocity. Now getting into the actual article itself, the article was titled NASA System Predicts Impact of Small Asteroid. So the name of the asteroid is EB5, and it was a small asteroid that hit Earth's atmosphere over the Norwegian Sea on March 11, 2022, so a couple weeks ago. But astronomers were already aware of its collision course and exactly when and where it was going to impact. But how were they able to predict this already? So NASA's SCOUT system, which is the system that I had brought up in the beginning, is a impact hazard assessment system that was able to take early measurements of the small object to calculate the trajectory of the EB5. So the system SCOUT that was able to utilize the trajectory of EB5, the asteroid, determined that the asteroid would enter the atmosphere southwest of Jan Mayen, a Norwegian island nearly 300 miles off the east coast of Greenland and northeast of Iceland. And then at 5:23 p.m. on March 11th, the EB5 hit the atmosphere as predicted by the system SCOUT, and infrasound detectors had confirmed the impact occurred at the exact predicted time. I thought this article was particularly interesting because scientists and astronomers were able to utilize this system to track these very tiny asteroids that were in this orbit. And hours before, they were able to prepare for an exact placement of this asteroid and possibly stop it from affecting people that were in that area. And asteroids like the EB5 are numerous and they impact the atmosphere frequently, about 10 every 10 months or so. So if we take a larger asteroid with a hazardous impact potential, it could be discovered much more quickly by this trajectory tracker, because it's not as small and we're going to be able to see it. It's going to be brighter. So this technology is going to be useful to NASA because they can keep track of these asteroids and calculate their trajectories in order to have years notice ahead of a potential impact should one ever be identified. So as this technology and surveys become more sophisticated and sensitive, more of these objects that are seemingly harmless, but they could vary in size, will be detected before even entering the atmosphere. I thought this article was very interesting because asteroids, whether that be big asteroids or smaller asteroids, are very numerous. They happen about every 10 months or so. And if NASA is able to utilize these trajectory tracking devices and these advanced technologies to calculate trajectories of these asteroids that are going to be in this circular orbit, they are going to have years of notice before they make any type of impact into the Earth and are going to be able to identify when they're going to make contact with the Earth. And it just gave these communities confidence in their prediction models. And so I think the response is going to be a lot faster. It's going to go from hours to years or months. So these are my sources, and yeah, thank you so much.